So this is a free body diagram in Newton number 2 for a skier being towed up a hill. So let's say we had a 75 kilogram skier, and skier is pulled at constant speed up a snow incline. The steepness of the incline is 20 degrees, and after drawing the free body diagram, we'd like to know what the normal force of the incline on the skier is, and we'd like to know what the tension force on the skier is, assuming that there is a kinetic frictional force of 50 newtons, and for easy numbers that the acceleration of gravity is 10 meters per second per second. So here's my free body diagram. I've drawn the slope inclined at theta with respect to the horizontal. I'm going to use a coordinate axis that's also tilted with the x axis pointing uphill parallel to the slope in the direction that the skier is being pulled, and y-axis perpendicular to the x-axis and perpendicular to the slope vertically upwards. So the skier has a weight mg acting on them vertically down. It has a tension T of the cable parallel to the slope pulling them up. It has a normal force of the slope acting on them perpendicular to the slope, and a frictional force, a kinetic frictional force opposing the motion. So what we will do is we'll take the weight, the mg, and we're going to divide that into a component perpendicular to the slope pointing down. That's mg cosine theta. The incline angle is the same as this angle between the vertical and the mg cosine theta force, and then a force mg sine theta that's acting downwards and parallel to the slope. So let's write Newton number 2 in the y direction. Newton number 2 in the y direction is n minus mg cosine theta is equal to 0. So in other words, n is equal to mg times the cosine theta. That's 75 kgs times 10 meters per second times the cosine of 20 degrees. That works out to 705 newtons. Newton number 2 in the x direction is t minus mg sine theta minus f sub k. And that's also equal to 0 because the acceleration in the x direction is equal to 0. So we can solve that for the tension. The tension is therefore just mg sine theta plus f sub k. So that's 75 kgs times 10 meters per second times the sine of 20 plus 50 newtons. That works out to 307 newtons. That would be the tension in the cable responsible for moving the 75 kilogram skier up the slope. Question for you: what T is required if we were to accelerate the skier up the slope at 0.5 meters per second, assuming the same values for everything else, same friction, same mass.